Hello everyone, so welcome to 7-Minute Classroom. So in this class we are going to talk about critical angle and total internal reflection. Okay, so let's get started. So first of all we'll discuss about what is critical angle. Suppose this is a straight line and this is the normal. Okay, so a light ray goes from here. So this is the denser medium. Okay, this is the denser medium and this is the rarer medium. That means this light ray, that means this is a light ray. Okay, this is a light ray which goes from denser to rarer. So at that time we know that when the light ray goes from denser to rarer, the light ray will bend away from the normal. That means it will bend away from the normal. Like this is the normal. I am just mentioning that n and n dash. That means this is the normal. Okay, this line. And when the light ray move from denser medium to rarer medium, it will move or it will bend toward the like it bend away from the normal. Okay, so that's how it looks. So this is the angle of refraction. I'm just denoting it by theta r, and this is angle of incidence. I'm just denoting it by theta I. This is angle of incidence and this is angle of refraction. Okay, so here this is what, like when the light is just refracted. So in this way, suppose I'm just going to draw another straight line here and I'm just going to draw another normal. Okay, and here I'm just giving another light ray which is also going from denser to rarer. So it will also bend away again. Okay, so that's how it again also bend away. So in this way, in the same process, if I just draw another, like I'm just drawing another which is also another normal, and there is the denser medium and there is the rarer medium. Okay, so suppose there is a light ray. Okay, light ray, this is going from denser to rarer. So if suppose, like we have seen that when the light ray goes from denser to rarer, it bends away from the normal. Like this way it bends away, here it also bends away. In this way, if it bends towards that line, okay, that means it goes through the straight line. So how much angle is just produced here? That is 90 degree. So here, what is the angle of refraction? That will be, like there will be theta r equals to 90 degree, and here our theta I or angle of incidence. That means when, if I am just giving like giving the conditions or for what there, like this will be critical angle, that means the angle or the light ray must be moved from denser medium to rarer medium, and the angle for which the refracted angle will be 90 degree, that is the critical angle. So I hope you understand. I'm just repeating it again. That means there is an incidence angle, so and there is a like refracted angle. Okay, so that means when the rays of light move from denser medium to rarer medium, for which like the incidence angle for which the refracted angle become 90 degree, it is 90 degree. That will be called critical angle. That means this angle will be called critical angle, and at that time we denote it by theta c. Okay, so I'm just erasing the whole thing, and again I'll just draw another figure to explain you more clearly. Okay, I'm just drawing another figure. Suppose I'm just drawing it here. Suppose this is the normal. Okay, I'm just mentioning it by n dot. Okay, so this is the normal, and here I'm just supposing like this is the denser medium, so I'm just denoting it by refractive index water, suppose, and here I'm just denoting it refractive index by air. Okay, so this is water and this is air. That means this is the denser medium and this is the rarer medium. Okay, so when the light ray pass from denser medium to rarer medium, it bends away from the normal. So when I'm just mentioning it here, when light rays moves from denser to rarer, when light rays moves from denser to rarer medium, it bends away from the normal. Got it? So when the light rays will move from denser to rarer, it bends away from the normal. So it will bend away, and at a time like bending, it will just bend through here, it will just bend through here. Suppose it will bend through here, it will bend through here, it will bend through here. At a stage it will bend by here. Okay, so when it bends through here, that means at that time this light will not be here. So the angle for which the refracted rays, the refracted angle becomes 90 degree, and it moves from denser medium to rarer medium, it is known as critical angle. So that means that will be theta c, critical angle. Okay, so now I'm just going to show you a kind of like equation. So what will be like for critical angle? Okay, so for critical angle, if I just thought like here, I'm just taking that theta I equals to theta C. Okay, I'm just considering the angle of incidence equals to critical angle. Okay, and I'm considering theta R, that means angle of refraction equals to 90 degree. Okay, because when this is a critical angle, at that time the refracted angle must be 90 degree. This is the condition. Okay, so for being a critical angle. Okay, so for critical angle we have get two conditions. Okay, so I'm just writing the conditions. Okay, two conditions for critical angle, two conditions. So what is the number one condition? It will move from denser to rarer. Denser to rarer. That means the light rays will move from denser to rarer, and at that time the refracted ray will be 90 degree. Refracted ray, okay, you can just give here refracted angle. Refracted angle will be 90 degree. That means these are the two conditions for being a critical angle. It must be like the light rays must be moved from denser to rarer, and the refracted angle must be 90 degree. Okay, so when the refracted angle will be 90 degree, then there is an angle which is known as critical angle. That means at that time the incidence angle will be critical angle. Okay, so this is what about the critical angle. Okay, so now let's talk about more about the critical angle. Okay, so now we are going to show equation. Okay, so if I'm just thought like angle of incidence, that means theta I equals to theta C, which is represents the critical angle. And again theta R, that means refracted angle, equals to 90 degree. Like we know that when it is a critical angle, then must be the refracted angle will be 90 degree. Okay, so suppose here is NW, that means the refractive index of water. Okay, it equals to sine, here you have to mention term what is sine. Okay, you have learned it about in like trigonometric ratios. Okay, so here I'm just like thinking that sine here, that means theta C. Okay, so first of all I'll just consider it at theta I equals to NA. So that means this is what about I have written about the denser medium. Okay, then I'm going to write about the rarer medium. Refractive index of air sine theta R. That means first of all I have written the theta I and theta R. Then I will write theta C and theta 90 degree. Okay, so now I'm just here I'll just change the values. NW sine theta I equals to theta C, then NA sine theta equal will be 90 degree. Okay, so this is now if we are just going forward to this equation, here you can see NW sine theta C, NA sine 90 degree. So you know what is the value of sine 90 degree? The value of sine 90 degree is 1. We all know about it. Okay, so 1. So here I can just write sine theta C. Here if there is 1, the value of sine 90 degree is 1. So if we just multiply here NA into 1, then what will be? It will be NA, just NA after multiplying it. So here it will be NA, and I will just transfer this NW from this side to that side, so this will be divided that side. Okay, so NA divided by NW. Okay, so now again we just change this equation because we want the value of theta C, that means the value of critical angle. So what will be it? Theta C equals to, if we just change the sign from this side to this side, then there will be an inverse, sine inverse 1, and that will be in bracket multiplied NA divided by NW. Okay, so this is what the value, and yes, this ratio must be, that means the value of this ratio must be less than 1. Okay, because if the value is more than 1, then when you just calculate this value, you cannot find this value in calculator. Okay, it will just showing that the math is just error. Okay, so how do you just get this sine inverse 1? So now I'll just show you in a calculator. Okay, so if I'm just going to show you how you will just get that value. Okay, suppose how will just get it. First click in the shift button, shift, then click sine. That means shift in your calculator, shift plus sine. When you click on that button, first you have to click on shift, then you have to click sine. Okay, first shift then sine, then you will get this sine inverse 1, and then just multiply this ratio, then you will get the value. Okay, so this is the value, this is the equation for the critical angle. Now another question comes into your mind. Now we are just going to talk about total internal reflection. What is actually total internal reflection? Okay, so if I'm just going to erase all these things, I'm just going to total internal reflection. Okay, so what is total internal reflection? Suppose we are again drawing this. This is the normal. Okay, and here also I'm just like mention like this will be also denser and this is rarer. That means here also the light rays have to pass from denser medium to rarer medium. This is the light ray and it will pass from denser to rarer medium. Okay, so if suppose the angle becomes more than the critical angle, that means we have seen in the total like in the critical angle that the refracted angle must be 90 degree. That means here, but if it is more than 90 degree, then what will happen? Like suppose it ends here. Okay, that means it crosses 90 degree, then the angle will just form from there. That means it is actually called total internal reflection. That means the light ray just refracted, or the light ray is just going towards a medium, but it will again back to the same medium. Then what is it is known as? Then what will be it is known as? It is reflection. We know. Then this angle equals to this angle. If I am just draw the figure correctly, this angle equals to this angle. That means this is the angle of incidence and this is the angle of reflection. This is reflection. We know in the rule of reflection, for reflection, we know for reflection angle of incidence theta I equals to theta r. That means angle of incidence equals to angle of reflection. So here also the angle of incidence equals to angle of reflection. That means when the refracted ray becomes more than 90 degree, then the total internal reflection will be happen. So there are also two conditions for being total internal reflection. So now I'm just going to write the conditions. So what are the conditions? So first condition, it must have to, the light rays must goes from denser to rarer medium. Denser to rarer. And another, suppose if I am just like supposing this theta I equals to like capital I. That means because the angle is bigger than the critical angle, so I am just considering it as bigger I, or like the capital I. Okay, so if here I am just considering the angle of incidence as capital I will be greater than the critical angle. So these are the two conditions. That means the light rays have to pass from denser to rarer medium, and like the capital I, that means this angle will be more than critical angle, because here you can see it is more than 90 degree. Okay, so this is what the total internal reflection. So in this video we have talked about critical angle and total internal reflection. So if you have any kind of question, then please let me know in the comment section. I'll just try to reply. So that's for our today's class. If you have any question, let me know in the comment section. Thank you everyone. Assalamu alaikum.